Okay, today topic self-commutated by LC circuit. So in forced commutation, we have class A, class B, and class C, class D, and class C commutations are there. So in last class, we discussed class A commutation. So today we're discussing class B self-commutated by LC circuit. Okay, so the capacitor C charges up to in the dot as a positive pulse is applied to the SCR. So when the SCR is triggered, resulting current has two components. So the constant load current I load flows through the R load. This is ensured by the large reactance in series with the load and the freewheeling diode clamping it. Okay. A sinusoidal current flows through the resonant of LC circuit to charge up the capacitor with the dot as a negative. Okay. At the end of half cycle, this current will then reverse and flow through the SCR in opposition to the load current for a small fraction of negative swing till the total current through the SCR becomes zero. The SCR will turn off when the resonance circuit current is just greater than the load current. Okay, the SCR is turned off it if the SCR remains reverse bias for TQ is greater than or greater than T off. Okay, and the rate of rise of reapplied voltage is less than the rated value. Okay, so here the capacitor charges up. Okay, charges up in the position of positive. Okay, so at when capacitor charging at the positive mode, so a gate pulse before the gate pulse is applied to SCR. Okay, so when the SCR is triggered, the resulting current has two components. Okay, so that is load current and it flows to RL load. Okay, this is ensured by the large reactance in series with the load. Okay, and the freewheeling diode clamping it. Okay, so a sinusoidal current flows through resonant LC circuit to charging up the capacitor as a negative at the end of half cycle. Okay, this current will be reversed and flow through the SCR in opposition to load current for a small fraction of negative swing till the total current through the SCR becomes zero. So, okay, the SCR will turn off when the resonance circuit current is greater than the load current. Okay, so when SCR will be turned off, the resonance circuit current is just greater than the load current. Okay, so here we are so in class B cell commutation we are using LC circuit. Okay, so by using LC circuit, the thyristor will be turned off. Okay, so here uh, before starting the SCR, okay, so the capacitor, so we have to see in the circuit diagram. Okay, so this is class B circuit. Okay, here the SCR will be connected across the LC circuit and freewheeling diode. This is freewheeling diode. Okay, and here so the RL load will be connected across the freewheeling diode. Okay, so before triggering the SCR, the capacitor will be charging at positive mode. Okay, so before triggering so here the charging will be the so whenever we are giving a supply, so the supply will go into capacitor. Okay, so this will be charging. Okay, so the capacitor will be charged in positive mode. Okay, so whenever we are triggering this SCR, so what happens means the capacitor will be discharging through the freewheeling diode. Okay, so a sinusoidal current flows through the resonant LC circuit to charge up capacitor with the dot of negative at the end of the half cycle. Okay, so at the end of half cycle, the capacitor has charging with a negative mode. Okay, so the current will then reverse flow through the SCR. Okay, so here the current will be so reverse flowing through the SCR. Okay, So the reverse flowing of SCR current will be reverse flowing through the SCR. It is opposition to load current for a small fraction of negative swing till the total current through the SCR becomes zero. So this SCR will turn off when the resonance circuit current is just greater than the load current. So the SCR is turned off. The SCR remains reverse bias for TQ. So TQ is greater than T off and the rate of rise of the replied voltage is less than the rated voltage. Okay. So this is class B circuit. So for class B circuit, these are the waveforms. So so this is triggered. So this is triggered pulse. So for sinusoidal input, whenever we have triggering this SCR with this pulse Ig and the load current remains constant. Why? Because means the here at first the capacitor will be charging and current flowing through the SCR, and also here freewheeling diode also will be there. So there is uh, there is no opposition for the load current. So the current will be flowing. So the current will be constant. So current. So this is ith current. So the SCR current will be here like this, and width. So this width means the voltage. So voltage graph will be like this. So SCR voltage this is. So SCR graph will be like this. So at negative. So at first the voltage on SCR will be 0, and at negative. So the gate will be closed of SCR. So then it will be slowly increasing, and it will be like this. Okay. Next. So when you see a problem on class B a circuit, so a class B turn off circuit commutate an SCR of load current of constant is 10 amps. Dimensions of commutating components L and C. Then the supply voltage will be 100 volts. So here load current will be given. So commutating capacitor is charged to a supply voltage of 100 volts. Okay. Here, so the supply voltage also the commutating component L and C. Here the voltage will be charging 100 volts. Okay. So the peak resonant current I peak equal to V into root of C by L. So I peak equal to V means 100 volts. Here, so here V means 100 volts. Here root of C by L into. So we have to simplify this. This is up. So here C by L. Here C by L means so 15 by 100. Okay. 15 by 100 whole square. Okay. That is equal to 0.00225. Okay. So the SCR commutates when the total current through it reaches to 0. So this is corresponding to 0.73 readings after the zero crossing of resonant current. So the capacitor voltage at that instant is 75 volts. After the SCR is turned off, the capacitor is charged linearly by the load current. If the SCR is to commutate at twice, this is load current for a rated inverted grade. So SCR is turn off time will be 20 into 10 power 6 seconds. Okay. So 2 into I load into T equal to 75. Okay, 75C. So that implies C equal to 20.20 by 75 microfarad. Okay, so when you are simplifying this 15.33, that is approximately 15 microfarads. Okay, capacitor will be 15 microfarad, and L equal to C by 0.0225. So that is implies to 667. That is equal to approximately 700 microfarads. So the reapplied forward voltage has dV by dt. Here dV voltage will be 20 and dt will be 15 seconds. So total 1.33 volt second rise. Okay. So it can be observed that if the peak of the commutating current is just equal to the load current, so the turn off time would be 0, as the capacitor would not be able to impress any negative voltage on the SCR. Okay. So next, class C. So C or LC switched by the another load carrying SCR. Okay, so this configuration has two SCRs. One of them may be main SCR and the other will be auxiliary. Both may be in load current carrying main SCR. So main SCR. So the configuration may have 4 SCRs with the load across the capacitor with the integral converter supplied from the current source. Assume SCR2 is conducting, so the capacitor is charges up in the polarity shown. So SCR1 is triggered, capacitor switched across SCR2 via SCR1 and the discharges the current C, opposes the flow of load current in SCR2. Okay. So here we have seen in class C commutation we have two SCRs, so SCR1 and SCR2. So when you taking SCR1 will be main switch, so main device, and SCR2 will be auxiliary device. Okay, here the capacitor connected at the middle of two SCRs. Okay, so for example when SCR1 will be charging, so the capacitor will not charge. Okay, so when SCR2 will be charging, so capacitor will be charging and discharges through the SCR1. Okay, so here we have to see in the load flow diagram. So SCR1 triggered, and SCR2 triggered waveforms. So V load, so total load voltage will be, so whenever the T off will be applied, so the load waveforms will be like this. And VC means capacitor voltage also will be at starting will be like this. So load current remains constant. Why? Because here two SCRs will be connected in parallel. So the load currents will be constant. Okay. And next, class D commutation. So class D or LC or T switched by an auxiliary SCR. Okay. So class D commutation we are also called LC circuit and also called C switched by an auxiliary SCR. Okay. So the circuit shown in figure. So in this figure shows class C can be converted to class D. Okay. So class D can be converted to class C if the load current is carried by only one of the SCRs. The other is an acting as auxiliary turn off SCR. So the auxiliary SCR would have resistor in its anode lead of say 10 times the load resistance. Okay. So the class D commutation will be converted. Class C will be converted to class D. Okay. So here two SCRs. So here the SCRs, two SCRs will be there. Okay, so this is main SCR and this is auxiliary SCR. Okay, here freewheeling diode also provide and the load will be resistor and inductor. Okay, so here inductor and diode will be connected across a auxiliary device. Okay, so these are the class D turn for class D commutation by SC or LC switched by an auxiliary SCR. This is a class D commutation circuit. And when you see a waveforms, so at first the gate, so the gate will be triggered. So the gate will be triggered. IG will be will be like this, and auxiliary device waveforms are triggered. So here, so in negative cycle, the auxiliary SCR will be triggered. So the V load means load voltage. So load voltage waveforms will be like this. Okay. So at starting, So whenever the SCR will be triggered, the load voltage will going to increase. So it will be going on increase. Whenever, so after the SCR, so auxiliary SCR will be triggered and it will be going increasing and also discharging. So discharging in negative cycle. So in load circuit, the load voltage will be discharges through the freewheeling diode. Okay, so same in negative half cycle. So VC means capacitor voltage. Here the capacitor voltage will be like this. As starting, the capacitor will be charged. So before triggering the SCR, the capacitor will be charging. So whenever the SCR will be triggered, so this capacitor voltage decreasing and it will be going in reverse voltage. So and it will be discharging through the SCR. Okay. So so in negative half cycle, the SCR will be discharging. So it will be going on increase. And whenever the auxiliary SCR will be triggered, so whenever the auxiliary SCR will be triggered, then again the capacitor will be charging. So it will be continued in negative cycle. Okay. Constant and again will be discharged. So at first thyristor, so main thyristors will be triggered. So the SCR will, the capacitor will be discharging. So in negative half cycle, it will be discharging. Okay, so it will be going on increasing. Okay, so when means so the capacitor voltage will be charged means through the auxiliary SCR. Okay, so before starting of main SCR, the capacitor will be fully charged. Whenever this SCR will be triggered, the SCR will be discharging through the auxiliary SCR. Okay. So the load current remains constant. Why? Because means here 2 SCRs also will be there. So that's why the load current will be constant. So this is class D or LC or C switched by an auxiliary SCR. Okay. So SCR must, so whenever the auxiliary SCR must be triggered first in order to charge the upper terminal of capacitor as a positive. As soon as C is charged, the supply voltage SCRA will turn off. Okay. So whenever the auxiliary SCR will be triggered, so the capacitor will be charging. So the charge to a supply voltage. So the capacitor will be charged to a supply voltage and the SCR, so auxiliary SCR will turn it off. So whenever the SCR will be charging through the supply, so sorry, here the capacitor will be charging through the supply voltage. Okay, supply voltage, the auxiliary SCR will be turned off if there are substantial inductance in the input lines. Okay, substances in the inductance in the input lines. Here we have seen, here inductance will be there in input lines. Okay. So the capacitor may be charged to a voltage in excess of supply voltage. So this extra voltage would discharges through the diode inductor load circuit. Okay. So the extra voltage will be discharging through the, so this extra voltage will be discharging through the diode and inductor. Okay. So whenever the SCR, so whenever the main SCR will be triggered, the current flows into two paths. One is load current flows through the load and the commutating current flows through the C and SCRM, C capacitor, SCRM and inductance and diode. Okay. So the charge on C is reversed and held at level by the diode. When the SCRA is re-triggered, the voltage across C appears across the SCRM. Why SCRA? So and the SCRM is turned off. If the load carries a constant current, the capacitor again charges linearly in the dot positive. Okay. So what is so in that class D commutation, two thyristors will be there. So one will be auxiliary thyristor and another will be main thyristor. Okay, whenever the SCR auxiliary SCR will be triggered, so to charge upper terminal of capacitor will be positive as soon as C is charged to a supply voltage. Okay, so by whenever supply voltage will be giving, so the SCR will be fully charged. So sorry, the capacitor will be fully charged, so the SCR will turn off. So if there is a susceptance inductance in the input lines, okay, so the supply voltage will be excess of voltage will be discharging through the capacitor. Okay, this extra voltage will discharge through the diode inductor load circuit. So the extra voltage will be going diode inductor. Okay, so whenever the main SCR, so this main SCR will be triggered, the current flows into two parts. One is load, so when it is triggered, so when one is flows through the load side and another one will be flows through capacitor and auxiliary SCR and inductor and diode. Okay, so the current whenever the main SCR will be triggered, the current flowing through two modes. Okay, so this is class D commutation. So when you see one example on class D, so a class D turn off circuit has commutating capacitor of 10 microfarad. Okay, the load constant is clamped inductive load such that the load current is reasonably constant at 25 amperes. So the inverted grade SCR has turned off time of 12 milliseconds. So determine whether SCR is satisfactorily commutated. Also dimensions of commutating inductor. So the supply voltage will be 220 volts DC. So here the capacitor is initially charged to a supply voltage of 220 volts at the end of conduction period of auxiliary SCR. So here the supply voltage will be given for the conduction period of auxiliary SCR. And when the SCRM is triggered, the 25 amps of load current and the LC ringing current flowing through it. Okay, so peak current through SCR is, so I peak current through SCR equal to, so here triggered SRM triggered that 25 amps. So the load current is will be 25 amps plus supply voltage B equal to 220 into root of C by L. Okay, so from selecting L such that I peak approximately 1.5 load current. So when we see taking 1.5 load current will be I peak, then root of C by L equal to 25 by 2.220. That is simplifying 0.05678. So already we have known the capacitor 10 microfarad. So that is we are simplifying. We have getting inductance 3.1 millihenry. Okay. So assuming that capacitor is charging to 70% of its original charge because of losses in the capacitor and the main SCR LD network. So and it is discharges linearly through when auxiliary SCR is again triggered. Okay, so I load into TQ equal to, so 10 into 0.7.220 into 10 power 6. So that will be simplifying 1540.10 power minus 6. Okay, so that time TQ equal to 1540 by 25. That will be simplifying 1.6 microseconds. So the SCR can therefore be successfully commutated. Okay. So the maximum current that can be commutated with a given capacitor at 220 volts supply voltage I load equal to 1540 by 12. So that will give 128 amps. For the 25 amps of load current, capacitor is just enough would have the rating. So capacitor C equal to I load into TQ. So by 0.7220. So that will be simplifying. So the capacitor will be 2 microfarad. If your supply voltage is reduced by a factor of K, the required capacitor rating is increases by the same factor K for the same load current. Okay. So next, class E are external pulse source for commutation. So a transformer is designed with a sufficient iron and a air gap. So as not a saturate, it is capable of carrying the load current with a small voltage drop compared with the supply voltage. So SCR1 is triggered, current flows through the load pulse transformer. To turn on the SCR1 off, a positive pulse is applied to a cathode of SCR from the external pulse generator via pulse transformer. So the capacitor C is only charged to about 1 volt, and the duration of turn of pulse it can be considered to have zero impedance. Thus the pulse from the transformer reverses the voltage across the SCR, and it supplies the reverse recovery current and holds the voltage of negative for the required turn off time. Okay. So this is the class E source. So in class E pulse source, we are using pulse transformer. Okay. Here the SCR will be connected to a pulse transformer and it will be connected to a capacitor. Okay. So when we're seeing a waveforms, so class E are external pulse commutation waveforms. So these are the triggered thyristor triggered waveforms, and current will be so the IA current. So thyristor current will be like this, and di by dt. So SCR change in current will be going waveforms like this. So SCR voltage at the negative side, the SCR voltage will be applied. So V pulse. So voltage and pulse transformer on negative side will be, and I pulse. So pulse transformer current will be. So these are the waveforms of class E external pulse commutation. And next, class A or AC line commutator. If the supply is alternating voltage, so this is circuit diagram of class F. Okay, so this is also called natural commutation by a supply voltage. So a supply is an alternating voltage. Load current will flow during the positive half cycle with the highly inductive load. The current may be remains continuous for some time. Okay. So here this is a class F, and it is also called single phase full wave bridge we can call. Here 4 thyristors will be there, and here load will be inductance and resistance. Okay. So whenever we are giving a supply voltage, so the at first thyristor 1 and so this thyristor 1 and a load, and so this load, and it will goes to this thyristor, and it will be discharging like this. And after that, so the thyristor 2 load and this thyristor 2 dash. So these are the connecting. So whenever supply voltage will be sinusoidal, so the load current will be constant, and thyristor at first the thyristor 1 will not conducting. Whenever we are giving a trigger pulse, then thyristor will be, so when thyristor will be conducting up to half of the negative half cycle, the thyristor so the thyristor 1 will be triggered, and after half of the negative half cycle, the thyristor 1 will be triggered, and after that it will comes to 0. So then thyristor 2 will be triggering. So then thyristor 2 will be triggering. Okay, so this will be like this. So in this, the load current will be constant. So VDC means load voltage will be like this. At first, before starting of thyristor, the load voltage on negative half cycle will be increasing, and it will comes to 0, and it will be going on increasing on positive half cycle, and it will comes to 0. So this will be going on increasing and decreasing. Okay, so this is a class of natural commutation supply voltage waveforms. Okay, energy trapped in the load inductance is dissipated during the negative half cycle. Therefore, the SCR will be turned off when the load current becomes zero naturally. So the negative polarity of the voltage appearing across the outgoing SCR turned it off. If the load voltage persists for a rated turn off period of the device, the duration of half cycle must be definitely longer than the turn off time of SCR. Okay. The rectifier in supplied from a single phase AC supply voltage. The commutation process is involved. Here is representative of that in the three-phase inverter. Okay, the converter has a input inductance Ls arising mainly out of the leakage reactance of supply transformer. Initially, SCRs of TH1 and TH1 dash are considered to be conducting, and the triggered an angle of converted around 60 degrees. The converter is operating in the continuous conduction mode aided by a highly inductive load. Okay. So when the incoming SCRs TH2 and TH2 dash are triggered, the current through the incoming device can't be rise up instantly to the load current level. So a circulating current IS build up in the short circuited path, including the supply voltage VS, LS, TH. So these are the current flowing paths. So here IS equal to VS into sin omega t minus 90 degree by omega LS plus VS by omega LS into cos alpha, and Vs into cos omega t by omega Ls plus Vs into cos alpha by omega Ls. So here alpha is the triggered angle, and ISC VSC is shown in figure. Okay, so the expression obtained with the simplifying assumption of input inductance contains no resistance when the current rises in the incoming SCR, which is the outgoing. Okay. So this is about the class of commutation. Okay. So next, two transistor mode of SCR. So this is another topic of two transistor model of SCR. Okay. So silicon control rectifier is a silicon based semiconductor device, so which is used electrical circuit for switching operation. Although there are many different members are available in thyristor family, but the silicon control rectifier are so widely used that is, if the thyristor and SCR becomes mm, synonyms. So the construction and operational point of view, it is a 4-layer PN, 3-terminal anode cathode gate semi-control device. So this device has two states, such that on and off. We can turn it on by sending a gate current signal between the second P layer and the cathode, but we cannot turn it off by a control signal. That means we have to control upon it's turned on. Once it's a conduction mode, we lose control over it. So it can be blocked both forward and reverse voltage, but can conduct only in one direction. Okay. So operating principle of SCR can be easily understood by a true transistor mode. So this true transistor model, we have to learning the operation principle of SCR. Okay. So by using true transistor model, we have also told operation of SCR. Okay. It is also combination of P and N layers shown in figure below. So this is SCR, anode, cathode, gate, and junction J1, J2, J3. Here P, N, P, N, P, N. This is 4-layer. Okay. So this is an PN thyristor. If you bisect it through the dotted line, so whenever this two SCRs will be bisect through the. So whenever bisecting, so we'll get two transistors such that one PNP transistor with J1 and J2 junction, and another with J2 and J3 junction has shown. So this is basic structure and this is equivalence. Here we have 2-layer. So this is anode, gate, and cathode. Here two transistors will be bisected. This is PNP and NPN. Here J1 and J2 will have one side and J2 and J3 will be other side. Okay. So this is equivalent circuit of two transistor model. Okay, this is two transistor model equivalent circuit. Okay. So when we calculating the so ICC equal to alpha alpha into IEE plus ICC. Okay. So here so this ICC. So this ICC equal to alpha IEE and 2 plus ICC. Okay. So this ICC equal to alpha IE into, so this alpha IE. So alpha IE, this is emitter. Alpha IE into IC. So this is IC. Okay. Alpha IE. So this IC equal to alpha IE. So alpha IE into ICC. Okay. The emitter current of transistor Q1 is the anode current IA of the thyristor, and collector current IC1 is given by IC1 equal to alpha into IA plus ICC1. Okay. So when alpha 1 and ICBO1 are the current gain and leakage current respectively for a transistor Q1. Similarly, the collector current of transistor Q2 is IC2, where IC2 equal to alpha 2 into IK. Okay, so two IKs and two ICC2s. Combining two collector current IC1 plus IC2. So then anode current equal to 2 IC1 plus IC2. So this anode current equal to alpha. So this current will be alpha IA into ICC1 and alpha 2 into IE2. So IK into and ICC2. Okay. So when the gate current IC is applied to a thyristor, so the gate current applied, then the thyristor, so this IK current equal to IA into plus IGG. Solving for anode current IA, so IA equal to alpha 2 into IGG plus ICC1 plus ICC2 by 1 minus alpha minus 2 plus alpha 2. So where alpha 1 plus alpha 2 equal to 1, the anode current is suddenly attains very high value of approaching infinity. Okay, this is two transistor model. Here two transistor model, alpha 1 plus alpha 2 equal to 1. Okay. ఓకే, అర్థమైందమ్మా.